Welcome to Chapter 5 Micro Lecture, Database Processing. So what's the purpose of a database? A database is designed to organize and keep track of things. Generally, these are things that spreadsheets can't do. A spreadsheet's great at keeping track of a single function. Like I've got the roster of students in my class, the homeworks you've completed, the tests you've submitted. But a database, like the one at CCSU, would keep track of all of your student record, all the classes you've ever taken, the classes that you might have dropped out for, what you've paid so far to the university, what you've been billed from the university, whether you've bought the meal plan, what dorm you've lived in. And each one of those is going to be, if you think about it, a separate Excel spreadsheet. But together, they're going to become this database. And databases often have relationships. So everything's grouped into columns and fields, rows and records, tables and files. And there's something called metadata, which we'll talk about in a few minutes, that's really the data about data. It's going to describe what each field is asking. So you say, here's a field element. Oh, well, this is first name. Well, we can store between 0 and 50 characters. It's got to be only A through Z letters. It won't take any numbers. So metadata is really data about data. If we're going to connect tables together, we've got to define a relationship between each one of those tables. And that's where keys are introduced. Keys can be primary or foreign. And if you think about it, our most primary of keys is our social security number. It is generally the primary key in most fields in the IRS, and it used to be the primary field in the student information system. And it was a unique key. And so if I had to look at a single student, I would say, hey, in every table that talks about that student, I'm going to embed their social security number. So as we said earlier, metadata is data about data. It's going to be something that's going to describe the data. It's going to make it more useful. So if we were storing a field like first name, well, the metadata for that may be how many characters we're allowing to be in a first name. Maybe it's between 0 and 50 characters. Do we allow just letters A through Z, or do we allow numbers in there? Does it have to be uppercase or does it have to be lowercase? All of those sort of specifications are metadata. Another easier, perhaps, way to look at metadata is find a picture on your desktop, right-click, and click Properties. When you look in Properties, you'll find out where that picture was taken. If it was taken on a phone, you'll see some GPS coordinates. You'll see what kind of device took that picture, how many megapixels it was. It'll give you all sorts of information about the picture without actually showing you the picture. So databases are managed by something called a database management system, or DBMS. And that's really going to be a program that's going to administer the database. If you're going to be a database administrator, as a role, you're going to use a DBMS piece of software to sort of manage the database. It's going to help you do security, get reports, give users access, tell you about the health of the database, reindex. And some examples of a DBMS are Microsoft Access, Oracle, SQL, DB2. The primary function of a database management system is to create tables and relationships in databases. The other thing that it's often used for is looking for corrupt data. Let's say we've got a prefix field where we're looking at Mr., Mrs., Miss, is doctor, is prefixes. Well, we want to make sure that we're storing all of that data the same way. Well, we may find, because there was a poor input mask, that in some places we stored Mr. as MR, and in other places we stored it as MR period. And so we might use a DBMS to do a find and replace and find all of the MRs and replace them with the MR period. So the four main DBMS operations: read, insert, modify, and delete. And let's talk about them real quick. So when we talk about DBMS, we really need to talk about what is a database application. A database application is this collection of forms and reports and queries that are going to go to use the database. If you went into Microsoft Access has the actual database tables, but it also has a form wizard, a reporting wizard. That gives you a sense of what are the other capabilities of the database application. You can also write queries in Microsoft Access, and that allows you to take a large set of data and maybe just look at a specific set of that data. When we look at forms and reports and queries, we just need to understand some basic things. Generally, forms are going to be used to insert, modify, or delete data. It's what the end users use to access a database. Rarely are end users going to go right into a giant spreadsheet or table and start typing into it. And it's very tough to enforce input controls there. So if we would have a form on a website, or we would have a form on a form page, and we might say, okay, we want to enter zip code, and we're going to allow 6 digits, and that's it. And we can use our form to sort of help enforce some of that integrity. Reports are going to show us the data. Sometimes they'll query multiple tables and multiple databases. And sometimes when you get into bigger places, they're going to create data warehouses or data marts. And if you think you might want to be a DBA, those are great places to go and look. And queries are a way of sort of rounding down the answers. It's a lot like pivot tables in Excel. You can give a query some commands. So I only want to look at things in a certain date range. I only want to look at them in a certain order. Let's sort them so that they're this, or only show me something that's greater than 50. And it's going to return to you only those results. Now, when we have a database, the intent is usually that multiple users want to get in there at the same time. And so there's a couple of things that we've got to worry about. Mostly, what would happen if 2 people had the same record open at the same time and they were making different changes? And so one of those things that could occur is called a lost update problem. And that's when I open a record and say someone else, we'll call him Bob, opens a record, and we're both changing different parts. He updates and then I update. Well, my update is going to overwrite his update, and it's going to contain the fields that we both pulled over when we opened it. A way to protect from that is to lock the record. And that way, if one person has the record open, no one else can open that record. And that makes sure that sort of one person or one transaction can't interfere. The only problem is that sometimes people want to go in and look at a record, and they find out from the system that it's locked. So a couple of differentiations in the database world. We've sort of got the enterprise DBMS packages. That's going to be the SQL Server, the Oracle, the DB2. And then we've got a personal database. Personal databases are generally going to support less than 100 users. Access is a great personal database. Paradox, FileMaker, if you're an Apple fan, those are all great personal databases. They work up to about 100 users, and then you sort of outgrow them. The database really can't support more than 100 concurrent users. So it's important to understand that most even small businesses are using enterprise DBMSs. And usually personal DBMSs are used for, basic small order entry, things like that, where you've got 2 or 3 people that just need to share some data. That's the end of our micro lecture. Have a great day.